All right, so today, this is going to be lesson 2. Lesson 2, we're going to look at polyatomic ions. Now, what I did, I believe I linked a Khan Academy article onto lesson 2, and then I'll put this little video in there as well to kind of show you what you need to be able to do. But basically, these polyatomic ions, and you'll find a bunch of those on this ion sheet that I gave you. So keep that handy as well as your periodic table. But polyatomic ions, I'll give you a couple here. We have, for example, sulfate, SO4 2-. Okay, what's going on here is this entire entity has a 2- charge. So SO4 minus 2 means that the whole thing has actually gained 2 electrons. And so you're talking about sulfur, 4 oxygens, and the entire thing, each of these would be an atom. And then this whole thing has gained 2 electrons. Now, why did it gain 2 electrons? Well, if I put it with, say, a zinc atom, zinc tends to give 2 electrons away and become 2+. So those 2 electrons that zinc had end up on the sulfate, and zinc, being that it lost those 2, is 2+. So you could actually form a compound here we call zinc sulfate. Okay, and let's try another one here. Maybe we have phosphate, PO4 3-. Okay, so we're talking about a phosphorus atom joined to 4 oxygen atoms, and maybe that phosphate joins with something like silver this time. Now, silver tends to form a +1 ion. So in this case, you wouldn't have a 1-to-1 ratio like you did here, 1 zinc for every 1 sulfate. You would actually need to have 3 silvers. Now you're thinking, where's the 3 come from? Well, just like the crisscross technique with binary ionic, this -3 here would actually, you'd bring that 3 down to your number of silvers, and then the 1 would come down here for the phosphates. You'd have PO4, and that would be silver phosphate. Now, you do have some cases where you might need to use parentheses and reduce. Say, for example, you're working with tin 4, so it would look like, tin. Let's see here, tin 4. Then maybe you want to go tin 4 carbonate. Tin 4 carbonate. Okay, so here's tin 4. I look at my ion sheet, and carbonate is CO3 2-. All right, so there we go, CO3 2-. And then I'm gonna switch these numbers. The charge of the anion becomes the number of the cation. So we're gonna go SN2, and now I gotta use parentheses, CO3, and this 4 is gonna come down here, okay? Now you can see the 2 and the 4 would be reducible, so I would rewrite that, SN, parentheses, CO3, 2. So if I particle diagram that, what I would actually have is 1 tin at a 4+, 1 tin atom at a 4+, and then 2 carbonate polyatomics at a 2- each, and I would put those on either side, so that would look like this. And you could put the -2 there. So if you think about it, I got a +4 in the middle, and then a -2 there and a -2 there, so the whole thing, that whole formula unit would be neutral. Okay, and if I put that in water, it would actually dissociate into those respective ions. I would get a carbonate, another carbonate, and then another tin. Okay, so let's just show you one more. Maybe we do something like we'll go copper 2 nitrate, and don't forget the Roman numerals with your transition metals here. Okay, so copper 2, I'm going to have Cu2+. My nitrate polyatomic is NO3 with a -. You're going to do your crisscross technique there. So Cu1, leave the 1 out, parenthesis NO3, and then this 2 comes outside from the copper. And you got to have those parentheses because what you're saying there is I have 2 of the nitrates, okay? I don't fool with the subscripts that are on the actual polyatomics, so I'll always have NO3. I can't reduce that. So that would be copper 2 nitrate. So what you're going to do today for your actual assignment, to submit your actual assignment, you're going to find a graphic organizer on Canvas. And if you want to, you can print it, then you can fill it out directly on there. You'll take a picture of that and you'll submit it in the assignments folder on Canvas. Now, if you don't want to take a picture of it, you can just recreate this table. Basically, take a piece of paper. You're going to have iron 1, zinc, ammonium, aluminum, and tin 4 across the top. Then you're going to have phosphate, sulfate, nitrate, carbonate, and bicarbonate on the left-hand side. So your anions are going to be on the left-hand side, and your cations will be across the top. And then you basically just fill this in terms of, for example, if I was going to create zinc sulfate, okay, so I'm going to bring the zinc down. So I'm going to go ahead and just do the name first. I'm going to go zinc sulfate, and then I'll write the formula. And you might show a little bit of work in here if you want to. So I'd have Zn2 plus, sulfate is SO4 2 minus. I'm going to crisscross, and I can see that's going to reduce, so it's going to be Zn, it'd be 2, and then the 2, but I'm going to just leave that off, SO4. Okay, and then maybe I'll try a couple more here. Maybe you go, how about aluminum carbonate? So we're going to go aluminum carbonate, a little tight there from the writing. Now aluminum's a 3 plus, carbonate CO3 2 minus, crisscross Al2, parentheses, I need the parentheses in the polyatomic, CO3, then I bring that 3 here. So that would be aluminum carbonate. So you're basically, let me show you one more, one that's reducible here. Let's go up here, we're gonna go tin 4 sulfate. Tin 4 sulfate is the name. And we're gonna go SN4 plus, sulfate is SO4 2 minus. Crisscross and reduce. Now in this we're gonna have SN2 parenthesis SO4 4, but I can see that's gonna reduce. So I'm gonna go SO4 2. And that's my final answer for tin 4 sulfate. So you're going to fill out this organizer, again, whether you create your own or actually print one and fill it out, and then you're going to take a picture of this completed, and you're going to submit it in that assignment folder on Canvas. All right, have a good day.